Geophysics is the study of the physical properties of the Earth using principles of physics. It involves methods to measure properties like density, magnetic fields, and seismic waves, which help us understand what is under the surface of the Earth. In petroleum engineering, this means locating oil and gas reserves and determining how to extract them. So, how does geophysics serve petroleum engineering? In simple terms, geophysicists use various tools and technologies to provide crucial data that guides petroleum engineers throughout the exploration and extraction process. Let's focus a bit more on seismic methods. When seismic waves are sent into the Earth, one part of the waves travels through different rock layers at varying speeds, causing refraction of waves. The other part reflects off rock boundaries, such as oil reservoirs, and return to the surface. Simply, it resembles the echography used in medical diagnosis. The ultrasonic waves represent the seismic waves, while the human body represents the layers of the Earth. By measuring the time it takes for these waves to travel and return, we can detect the depth, size, and shape of the reservoir. This is vital because it allows engineers to assess how much oil or gas is available and how best to extract it. Seismic waves are generated by a source like a dynamite charge, a vibratory truck, or an air gun. The waves travel through the Earth, bouncing off different geological layers. We will have a brief on each one of these sources. Number 1. Dynamite charge. A small amount of dynamite or similar explosive material is placed at a specific depth in the ground, depending on the exploration needs. This can be done by drilling a shallow hole or using surface charges if the geology allows. The dynamite is then detonated, causing a controlled explosion. The explosion generates a shock wave of energy that radiates outward from the point of detonation, generating seismic waves. Number 2. Vibratory truck or Viprosius. It creates seismic waves by producing ground vibrations rather than explosive energy like dynamite. The Viprosius uses oscillating weight and hydraulic systems to generate the waves. In addition, it uses a pad that presses against the surface of the Earth, keeping the Viprosius in direct contact with the Earth. Number 3. Air gun. This source is mainly used in offshore drilling. The air gun is connected to a pressurized reservoir that holds compressed air. The air is stored at a high pressure, which allows the air gun to release a powerful burst of energy when triggered, which travels through the water and into the seabed below. The air gun is typically placed on the ocean floor or suspended in the water column by a floating vessel. It can be arranged in an assembly along a survey line, depending on the scope of the seismic survey. When seismic waves hit different rock types or fluids, they reflect back to the surface, where sensors called geophones pick up the signals. Once the seismic waves return, the data is processed to create a seismic profile. This is a map of the underground geology, showing us where oil or gas reservoirs might be located. The spacing or interval between geophones is a critical factor in determining the resolution and accuracy of the seismic data. The spacing depends on the geological settings and survey objectives. Number 1. Close spacing. In areas where high-resolution data is required, geophones are placed closer together. This helps to detect finer details of the subsurface, such as small faults, fractures, or thin layers. Number 2. Wide spacing. In areas with less complex geology or when the focus is on deeper subsurface features, geophones can be placed farther apart. This reduces the number of geophones needed, making it cost-effective when less detailed exploration is required. So why do seismic waves matter so much in drilling operations? Let's take a look at some of the benefits. Number 1. Accurate reservoir mapping. Seismic data allows engineers to accurately map the location, size, and shape of oil and gas reservoirs. Number 2. Reduced drilling risks. By understanding the subsurface structure before drilling, engineers can reduce the risk of drilling dry wells or encountering unexpected rock formations that could damage equipment or delay operations. Number 3. Optimizing drilling plans. With detailed information from seismic data, engineers can design drilling plans that optimize the extraction process, ensuring resources are produced efficiently. Number 4. Environmental protection. Seismic waves help in predicting geological risks like potential groundwater contamination, reducing the environmental impact of drilling operations. The more we know about the ground before drilling, the less likely we are to cause unintended harm. There are several types of seismic surveys used in drilling, and each one has its advantages, depending on the location and goals of the project. Number 1. Two-dimensional seismic surveys. This is the most basic type, where seismic waves are sent through the ground along a single line, providing a slice of subsurface information. Number 2. Three-dimensional seismic surveys. It is more advanced and are commonly used today. 3D seismic surveys create detailed three-dimensional maps of the subsurface, offering a much clearer view of the reservoir. Number 3. Four-dimensional seismic surveys. These more advanced surveys involve repeated 3D surveys with time as the fourth dimension to monitor changes in the reservoir during and after production. This helps engineers manage the reservoir more effectively. While seismic exploration is a crucial and widely used method in oil and gas exploration, it does have some drawbacks. Here are some of the key drawbacks associated with the seismic exploration. Number 1. High costs. While seismic surveys are relatively cost-effective compared to drilling, they can still be expensive, especially in large-scale or complex surveys. Number 2. Limited accuracy in complex geology, where seismic waves may struggle to penetrate hard rocks, complex fault systems, or fractured zones. Seismic exploration is less effective at detecting reservoirs located at a great depth and layers of similar properties. Number 3. Interpretation challenges. The interpretation of seismic data is complex and requires a high degree of expertise. Number 4. Potential safety risks. Vibration and ground shaking may lead to structural damage in nearby buildings. If explosives are used instead, they are considered hazardous materials that can pose safety risks if not handled properly. Number 5. Disturbance from other sources of noise. Background noise can cause signal distortion and make it more difficult to distinguish seismic waves from environmental noise. This can reduce the quality and clarity of the seismic data collected. Seismic surveys are just one part of the picture. Geophysicists also use gravity and magnetic surveys to study rock density and magnetism. These methods help map geological structures and identify oil and gas reservoirs that may not be immediately apparent through seismic data alone. Using these techniques in combination allows for a much more accurate and efficient exploration process, which means less time spent searching and more time spent drilling. As we have seen, geophysics plays an integral role in drilling operations. The tools and techniques used by geophysicists make it possible to find and extract petroleum resources in a more efficient, environmental friendly, and cost-effective manner. Geophysics is an essential pillar that helps drive the petroleum industry forward. If you found this video helpful, make sure to give it a thumbs up and subscribe to our channel for more valuable content. Thanks for watching and see you in the next video.